We are live. Hi, Samir. Welcome to Venture with Grace.
Hey, Grace, thank you for having me.
I've been so excited about this conversation because I feel like robotics is like such a huge thing in the AI space that it's been like covered in like a very I feel like it's like a really booming subsector of the entire AI era. And then maybe we could start with like your background so the audience can understand you a little bit more. So like you started your career as a researcher at your university, you have worked at Microsoft in the engineering and design arena, and then you were a PhD student at Stanford. Why don't we talk before you started your own company? Why don't we talk about what were some core lessons that you've learned early on in your career, kind of shape you into who you are today?
Thanks for the opportunity. And looking back, I've been working on physical AI robotics for almost 18 years now.
Mhm,
It's been a dream since I was a kid. And
mhm,
the interesting part is that robotics and AI has been more or less at the cutting edge of
mhm,
technology for a long time. It's a very, very sophisticated technology that
mhm,
combines software, AI, hardware. Looking back, when we look at robotics, the robots have been around for a very like decades now. You had
mhm,
robots in the 1980s, and I oftentimes have this opinion that robots can do anything as long as you make the environment really precise, because they're very precise machines. And the fundamental challenge with physical AI and robotics is to allow robots to operate in very unstructured environments with human-like skill and dexterity. And so a lot of my research when I was at Stanford was actually focused on trying to understand human motion with a particular intention to see if we could transfer human skills into robots. And so
mhm,
we had a lot of lessons learned, but the first and foremost lesson is when we have decades of technical progress, it's
mhm,
very important to have a good sense of how that technical progress is going to translate into solving real world problems. And
mm,
so the key events that led us to start Dexterity was a sense of confidence that the technology had evolved to a point where software and hardware could come together, powered by AI, to
mhm,
solve real world problems. We had a very good sense of real world problems in logistics, in parcels, and e-commerce and retail. And we said, hey, the time is right. Let's go for it. And it proved
mhm,
to be an amazing experience. So it just put us at the
mhm.
cutting edge of robots and physical AI now.
Mm, I love that. I want to start with like, I really like what you said about like, what are something that like research can help to actually create like a real life product? So why don't we talk about like, your original research at Stanford, which you have been worked on for like over 10 years, and then how do you kind of like find the research product fit before product market fit? I just made this up. Research market fit, but yeah, or research
Yeah.
product fit. Like, how do you kind of like translate like the your research into like an actual physical product?
I love your term, research market fit. I'm going to use that later. Let's see if it sticks.
Mhm,
With with research, I would say there's research is a very broad arena, and my research in particular was really focused on trying to get to the heart of what is it that allows us to move in a human-like manner.
mhm,
I move around. Well, what's necessary? And
mhm,
so, if we think about research, particularly in engineering,
mhm,
that we can use to solve real world problems,
mhm,
there are a few factors that are pretty critical.
mhm,
The first is your work needs to have sort of a holistic end-to-end nature to it.
mhm,
If you're working very deep in a nested corner of a sub problem that has extremely specific application, it's very hard for you to go out and solve real world problems. In order for you to solve real world problems, you kind of have to have somebody else do the 90,000 things that pull your advance into a product. And so with robotics and physical AI, we have the added challenge that the ecosystem has been developed alongside our work here. So the ecosystem for robotics was very focused on manufacturing. you see robots doing an amazing job in car manufacturing plants or semiconductor plants. And if we think about robots that do stuff with their hands in a human-like way, that requires a lot of infrastructure that just wasn't there.
Mhm.
So the lessons I think I had learned were not just from our research, but also from looking at 20, 30 years of robotic startups trying to enter the market and struggling because they position themselves in a weak manner.
Mhm.
So my takeaways were three front. One is you got to solve big problems. You've got to solve big problems. Where are the big problems? Well, the big problems are generally with the big customers. If
Mhm.
you go to smaller customers, you have thousands of smaller problems, and it becomes more of a probabilistic game. Did I just by chance, hit the right mark and got the right product fit, and suddenly it's like gone viral?
Mhm.
Those type of things are too risky in an application area where you need to invest a lot of capital. And for physical AI robotics, you do need to invest a lot of capital. So a big lesson that we learned was, hey, solve big problems. The least risky way to find big problems is to go to big customers. So that was the first lesson, is like, if you can't solve actual problems for very large customers, you might be in trouble.
Mhm.
The second part of that is, to solve these big problems for customers, you're going to have to do software and hardware. It's a very difficult to just focus on only doing software, only doing hardware, only doing AI, only doing algorithms, or any such thing, because that just doesn't get the job done. So you got to go to big customers, you got to go end to end, and that brings us to the third problem, which is going end to end with big customers is a very, very difficult thing to do. It takes a long time and requires you to have an intense focus for many, many years. So you got to raise good capital, and you've got to do things that each thing that you do is a stepping stone towards doing something better. I call that the platform approach. I think if we listen to, there's an excellent talk by NVIDIA's Jensen Huang, where I think he says the purpose of a platform is to make every incremental thing that you do easier than the previous one. And so as long as you keep on building this momentum, you keep on building this flywheel, you can go to large customers, you can go end to end, you build this platform type flywheel, and you get the job done and you keep improving. I think that's been our strategy. Those were the lessons learned. And looking back 7.5 years since we started Dexterity, it's panned out pretty well.
Mm. I love that. I think like I'm taking notes of like some of your philosophy. I totally agree on like getting big customer, because small customers like too risky, especially in the hardware space, just because like you are building a physical product. It's not like you're building a software like tomorrow you change like two features and you're good. I think like to start off like with the hardware, right? Like building that physical product from your research, like how do you kind of like, I guess, like research the customer? Like, let's say you're like, I guess like maybe I don't know if you feel comfortable just talking about like clients, like how do you think about like who do you partner with first, and then how do you kind of like get the big logo to be on like on your, I guess, like client list basically?
So being a PhD student at Stanford, it's a bit of an ivory tower. Everyone's quite shielded. People tend to be pretty introverted. They're really heads down, focused on their work. And one of the big lessons for me at the moment I got out of the PhD program was, it's so important to
Mhm.
build the right relationships with the right people. And that comes with being very, very humble. I would say there's a deep sense of respect that I've built for customers and their operations. When we look at large customers, I think the one hand, you can look at, hey, I've got this cool technology. It's going to help you in so many different ways. It's so obvious. You should just go ahead and adopt it. And there's no other way. And all those cool things that we get very excited about. But it's important to put ourselves in the shoes of the customer and have a deep empathy with the customer, where when we look at large customers, they are the backbone of the economy and our civilization, particularly as it pertains to e-commerce, logistics, retail. If those operations pause for a day, people go hungry at night and you don't get your
Mhm.
stuff, and the world falls apart. And we saw some of that happening during the COVID pandemic.
Mhm.
So I think it starts with a deep humility, a deep respect for the nature of responsibility that these customers carry, a deep willingness to bend over backwards to understand what is a non-disruptive way to go out and help them solve their problems. What is a way in which you solve the problem and it's also perceived positively in a social sense. The larger the customers get, the larger attention, sort of span of attention that they have from society. And you've got to do things right. You've got to do things safely. That's so critical. Safety just comes first for anything that's physical. So how did we end up having the opportunity to work with some amazing customers? We spent a lot of time trying to understand where they're coming from. We spent a lot of time trying to make sure that we position ourselves in a socially responsible manner. We spend an extraordinary amount of effort in making sure our systems are safe. We solve the problems, and we do so in a way that brings smiles to people's face. Hopefully, when our robots go in, people feel, "Oh yeah, look at that! That's an amazing mech." It's just like Transformer type robot I saw in the movies. It's going to help me load trucks. That sounds great. I don't want our robots to go in and people are like, "Oh no, this is kind of like this human type shape. It's been bought to replace me." So we've got to play the social aspect, the emotional aspect, and of course the commercial aspect. If you're not making money, then you have no business.
I want to start with like another question is like, I feel like for being a PhD student, how do you kind of like commercialize your work in general? So like, I guess like we just talk about kind of like building a product and, kind of like getting the bigger clients. I guess like maybe when it comes to like building the investor relationships, like I think any hardware founder would agree, like fundraising is probably one of the biggest challenge coming from the hardware aspect. Like how do you because the valuation could be like very challenging as like it requires so much capital to do so many things, but though like it's kind of like go big or go home. Like obviously you could build the next um Dexterity, but like on the other hand, the startup may like just die with a lot of capital. So like how do you kind of like convince investors and build the investor network to at the beginning fund the product?
Great question. I think when we think about some of the largest companies in the world today, there's NVIDIA, which has rocketed to the top. There's Apple. There's, of course, Google, Microsoft, but there's Tesla. SpaceX is huge in the private space. There's many companies that have built enormous businesses with a hardware and software component. When we think about the startup ecosystem, investors are investing probably with some sort of theme in their mind, with some sort of thesis that ultimately channels their capital to a startup ecosystem that's going to make a lot of money. So let's think about what it takes for a startup to be very, very successful. At the end of the day, you want to make revenue, and you want to scale that revenue and grow fast. You want to make sure that you've done such an amazing job that you are substantially and significantly ahead of your competition in every aspect. So the advantages of working on software, and with Dexterity, I would say we're maybe 60-70% of our efforts go into software. 30 to 40% of our efforts have gone into hardware. Earlier in the game, we were more exclusively focused on software, and we worked with a lot of partners to leverage the hardware. But when we think about maximum returns for capital, the capital needs to be invested in creating intellectual property and commercial momentum that will be unchallenged for a long time. And when we think about digital AI, let's look at what happened. With digital AI, initially we had our amazing AI models. OpenAI launched GPT. There was GPT-1, GPT-2. GPT-2, it started to look pretty promising, but it was nowhere close to being useful for a wide variety of people. And then GPT-3 launched, and GPT-3 was a pretty sophisticated AI model. On top of that, they had the ChatGPT application, and it was the application which ended up monetizing the core model. So let's draw an analogy to where it is today. Today, there are many different models. And a lot of the efforts have now shifted from the raw strength of the models to cost to serve. What's our capability to do deep research? What's our infrastructure requirements on the data centers? Can I buy a nuclear power plant to power my data center? I mean, that sounds like science fiction. 10 years ago,
Mhm.
you could have joked about it. I used to actually joke about it. It'll be like, one day we'll need these AIs, and to run them, you'll need a nuclear power plant. And that's what's happening. So they also make investments in hardware, in software, but you make it in a way that strengthens your product offering to your customers and your competitive mode. With robotics, physical AI, at the end of the day, you have whatever your core AI is, it's going to be running on a robot, and you'll have to build some applications that solve real world problems. In order to
I
do that, you need to just establish that the capital is going into your startup in a way that just creates long-term competitive momentum. And I think beyond that, if the investors believe you, then you get the capital.
I love that. So I wonder, like at the beginning, I guess like when it was like the beginning stage of fundraising, obviously now you guys are, you raise like hundreds of millions and then you're valued at a billion, like $1.6 billion and more. When at the very beginning, I guess like from the 0 to 1 stage, I like what you said about like I think what I thought was really interesting was you mentioned like you would spend 60 to 70% on software building, and then also before that you spend even more time on that. So in terms of like the intellectual property slash like the patents, like can you, let's say, I mean obviously now your business is very successful. Let's say if you and I starting like a company again from today, let's say if our company, the product didn't really pan out, if we sell the patent, can we sell a lot of money to that? Or like, is this like not like a business that's kind of like in like actual, that's not like an actual business? I'm just out of curiosity.
So intellectual property is not just the patent. Intellectual property is your ability to take a technology and execute and create products out of it in a
Mm,
commercially competitive way.
mhm,
It includes a lot of trade secrets, which you don't talk about. You just keep them. It includes your talent and what knowledge they have. When we think about robotics, physical AI today, if we were to start from scratch,
mhm,
it's I would say at the end of the day, solving problems, the most efficient use of capital is to work backwards from the customer. There are segments of the market that are in manufacturing that can be addressed by non-AI robotics,
mhm,
not super exciting for me to focus on. The moment you get out of manufacturing, you get into logistics, you get into stores, all of a sudden there's many applications that need AI because you need a degree of intelligence. Amazing.
mhm,
Focus over there. When we think about AI and software,
mhm,
there's work to be done on creating AI that is very general. You have to be able to have the same AI work on different applications, and you have to be able to make your same AI work on different types of hardware, because there's going to be many different types of robots. So if I were to invest capital at the application layer, I would go to places that are somewhat unstructured, but still enterprise controlled, somewhat controlled environments with lots of variations,
mhm,
numerous applications, tens of thousands, maybe hundreds of thousands of applications over there. If you go to the AI model space, I would make investments in building AI models that work across many, many different applications and work on many different types of robots. That way, you can provide those as part of packaged product. And
mhm,
on the hardware side, I would really, really focus on industrials. There's the core of the robot, which is the robot arms, the ability to move around. That's pretty mature. I think where
mhm,
we can benefit from advances in hardware are on, say, different types of hands that are actually built for AI. Right now, we just look at the human hand. It's actually not that useful. I injure my wrist like doing anything. I
mhm,
even get wrist surgery.
mhm,
What is a robust hand that will be amazing for AI to use? Nobody knows. And you
mhm,
do that, and pair that with the AI in a way that's very easy for other people to use.
mhm,
Amazing. If you just build pure hardware, you're probably toast. It's going to get copied, but it has to be full stack.
mhm. Oh, totally agree. As an angel investor, I actually invested in like a little robotic hand company. It's not a little company. It's like a early stage company, and they're based out of like Berkeley, and then there's a lot of like Berkeley PhDers building that product, which I can share a little bit later. But I guess like maybe when I guess like I want to start with the product. I think what you said really resonating with me is like you kind of separate them into different subsectors. So like there's a software piece, there is a hardware piece, and then there is, AI, and then like the competitive mode is like how do you leverage them into like a competitive commercialized product. Um some of your clients, like based off my research, you don't have to agree or not agree, but I guess like I don't know. I think those are like public information as they're on the internet. Like so, for example, FedEx or UPS. Those are some really big corporations. Like maybe we start with the product. So at the beginning, how do you created the robotic hand, a humanoid robot to kind of like collaborate with the human, and then how do you see it evolve into like fully automated, which is like now very automated, like I guess like how did that process exist like from the product level?
For us, it was very simple. We sit down with the customer, we talk to them, we look at their problem, we brainstorm together, and we build the product in a way that just solves the problem. So a lot of communication. The amazing thing is, if you're very clear about the problem, the solution kind of presents itself. For us, this came down to this amazing robotic system kind of inspired by Transformers that we call the mech. And it's got two arms. It's kind of got a wheeled base which can drive around. It's really minimalistic. You don't waste money on heads and other fancy, I don't know, jewelry or whatever you put on your robot to make it look really cool. It's an industrial beast. It's got two gigantic arms. It can drive around and it can just pick up these huge boxes and heavy lifting and load them into trucks. So I think the right answer to that is talk to your customers, figure out what is the simplest, cheapest, most robust, highest performance way to solve their problem. Do it. It's really not that hard, actually.
I wonder, so like how do you so at the beginning, like so you guys probably, I would assume you purchase like part of the hardware that's like existing in the market and then maybe program the software to make it smarter. Tell us more about like how do you like kind of like the first version of the product, how do you build the robotic hands?
So, again, I think just to add a little bit of flavor, I would say there's applications, there's AI, and there's hardware. The applications come from the customer. Obviously, they know what their problems are. Each application uniquely solves a problem. When we think about investing in hardware, investments in hardware have to go hand in hand with a strong worldview opinion on how AI should operate. So, anytime we invest in hardware, at the back of our mind is like, is this the best possible hardware for AI? Is it built for AI? Is it built just to copy something else? So for the hands in particular, when we think about the types of problems that have commercial relevance today, these are problems that require stressful, heavy lifting. Imagine if I were to ask you, hey, Grace, you've got two options. You can go out, pick 60-pound boxes for the next 8 hours in a truck that's like 110 degrees in the heat, right? Or would you like to sit in a nice air-conditioned coffee shop and be a barista and make some coffee? Which one would you pick?
Coffee.
You pick the coffee, right? There's nobody on earth who's going to say, I'm going to pick 60-pound boxes for 8 hours straight, loading this truck in the blistering heat. So if we want to be non-disruptive, if we want to have a positive impact on society, we want to focus our efforts doing these difficult, stressful, injurious tasks. And when you're in a difficult, stressful, injurious environment, you need something that's industrial grade as it pertains to the AI and the hardware. And so the AI can learn to control different types of things. When we looked at the hands in particular, you can have hands and fingers. You can have hands with what are called suction cups. These are little kind of like mini vacuum cleaners that kind of suck really hard. So you pick something, it kind of sticks to your hand, maybe a little bit like an octopus. And so when we think about what's easy for the AI to learn, it's very easy for the AI to learn how to use these suction cups. They're also very cheap. Like if you build a hand with fingers, each finger costs about $2,000. Each suction cup costs about $20, and they roughly break at the same rate. You deploy them in the field, they'll break around 4 to 6 months or something like that. And so every 6 months, do you want to spend $2,000 a finger times 5, which is 10 grand for a new hand, or do you want to spend $20 a suction cup times 5, which is like $100? So the customer is like, we're like, look, here's an opportunity. Here's 5 different types of hands. Customers, you take your pick and just let the market decide. So at the end of the day, it's better to be focused on solving the problem, giving different options to the customer, and let them decide what's valuable. Most of our customers just pick the suction cups. And so we built a huge amount of expertise in getting these octopus type suction cup hands. It's pretty cool. Super cheap. It just works.
So I love the pitch. So super cheap just works. But when it comes to like the AI component, like how do you implement AI into the traditional, suction cups, basically?
Amazing question. So there's a few interesting things over there. One is if AI has to control hardware, AI needs to interact with hardware. Now, if we look at most robots, as a human being, if somebody just taps me on the shoulder, I can feel it. I know exactly what's going on. With most robots, you tap a robot on the hand or the shoulder or whatever, it has no clue because there are no sensors. So the first step for AI to successfully control a robot is you need to add a lot of sensors. In particular, you need to give the robot the sense of touch. Most people over-index on vision because we use vision a lot. But the reality of the matter is when we're doing physical tasks with our hands, imagine I'm playing tennis. If I just watch the ball all the time, I will never make the shot. I only watch the ball when the other guy or girl just like flicks it and hits it with a racket. Once it's in the air, I have a mental simulation of where the ball's going to land. And then I'm more focused on just moving, positioning myself, and smacking the ball back. And so a lot of times vision is used to build a mental model of the world, and then you operate kind of in your own mental model of the world, and the sense of touch becomes very critical. So for us to effectively use any type of hand, we have to give the robots a sense of touch. We have to integrate this in a way that the AI could rapidly access this information and also control at a very fast rate. There were numerous improvements that we had to make. We worked with our manufacturing partners to create what we call Iris. It's kind of like a nervous system of robotics, and it connects. And so now you've got an AI. It's got the sense of touch. It can see, it can touch, it can really understand what's going on. And then you have to make sure that each and every finger can be controlled independently. And then you teach the AI, you collect a bunch of data and you train it as like, I should use these fingers when I'm doing this type of thing. I should use that finger when I'm doing that type of thing. Here's an object. I should grab it this way and that way. And lots of data, lots of training and learning later, you get the job done. But
I love that. So I find it super fascinating that you mentioned like the sensor versus vision. Why is everybody focusing on vision at the beginning, and then how do you like when it comes to sensor? Like you mentioned, like you put like a bit more sensor to it. Like I guess like what are they sensing to? It's not like they accidentally touch a box or like this box is like in this degree. I'm like, how is it different than the traditional, like, the pickup boxes? Like, maybe in the past it was like you use like a controller to like pick something up. But like right now, maybe people program it to like automatically when you see something, you pick up something. Tell us more about like how does the sensor kind of work versus like also why is everybody else pick like the vision?
So vision is very easy based on the smartphone ecosystem. There's a lot of cameras in smartphones. There's a lot of images that we process. There's almost 15, 20 years of work that's been put into processing images. And that work shows up. You can easily leverage all that work and start to make progress. There's also it's just a very striking, it's the most obvious sense that we have. It's the highest bandwidth sense. It takes you a very long way, by the way. Vision alone will take you 70, 80, maybe even 90% of the way. The challenge over there is if you actually want to succeed with a product in production and you want to solve real world applications, you need to get to that 99%. That last 9-10% becomes very hard with vision because your cameras sometimes won't be able to see. You might need to take multiple snapshots as you're doing your thing. You might just require 85 cameras on your robot or something like that to see every little nook and cranny, and it just gets more and more complicated. So vision's amazing. But the moment you touch, it starts to lose its charm because let's imagine I have my cell phone over here and I've got a coffee cup and I touch them. Now, how much force am I applying? If I apply too much force, I'm going to crush that cup. But my vision's not going to tell me. Like, sure, I could train a model that
Oh,
can look
okay.
at the small little distortions in the cup just before it's about to break, but that's pretty tough. And so if you don't have the sense of touch, you just go about crushing things. It's like the Incredible Hulk, like super powerful, breaks everything. So you got to have the Incredible Hulk with the grace and skill of a sushi chef. And
Mhm.
how do you package those together? So the sense of touch is almost a holy grail. It's not very easy to sensorize. You need touch, you need pressure, you need it to work really, really fast. And there's some very special secret sauce that I think few people in the world understand. We've made a lot of progress there, and it shows.
I wonder, so, like, I think that's so interesting that I've never really thought about, like, the crashing part, and then what is like, how do you think about, I guess, like, the profit margin as well? Which is because, like, I think building these, like, sensors probably costs a lot of money, but how do you kinda, like, shrink the cost? And then what were the original hardware process kinda, like, build, like, previously to, like, have the industrial grade robotics arm that actually applied in the business versus, like, now? How do you think about, like, cheapening the cost?
So for us, the strategy when it comes to hardware is generally been find a partner who already makes the sensor and
Mhm,
just figure out what's the best way to make that sensor AI compatible. So a lot of our efforts in
mhm,
hardware are actually focused on making the hardware AI compatible. And
mhm,
again, the bulk of our efforts are in making
mhm,
the AI work. So as it pertains to sensors, we make lots of friends in the
mhm.
US, in Germany, in Japan, in Taiwan, in India, and
A
uh,
warp tour,
other
basically.
places. We say, who's got the best sensor? And oftentimes, the best sensor is the most reliable sensor. Outright reliability and quality is just trumps everything else. And
Mhm,
so you find the most reliable, high quality sensor, you make sure it's going to work. And then you do all the things that allow the AI to access that sensor in real time, and you train your AI with information from that sensor. So our efforts on sensors are just focused on establishing quality, reliability, and then the connectivity to the AI that's going to be using the sensor.
mm. I wonder, so, like, I guess, like, how do you find where has the best sensor? Like, do you just Google search, or, like, do you have, like, an agent that does, like, the crawling? Or do you have a bot? Do you have a humanoid robot just sitting in your office that actually put this together?
No, it's actually very tough. That it's not that straightforward to answer that question, because it's not just that you found a good sensor. The question is, will this manufacturer be able to consistently deliver you this sensor over and over and over again with the exact same quality that they gave you the first one? And for that, you have to build good relationships with established manufacturing houses. One of the lessons that I learned is manufacturing quality is not something that comes very easily. It comes with a lot of time, a lot of investment, and the cost of malfunctioning sensors means that you could have a safety issue. Let's say
Mhm.
I've deployed my AI, and my AI is like, you know, gently doing something, but in reality, the sensor is off and it's just like smashing things. It just doesn't know. So the cost of the price you pay could be in safety, and that's just unacceptable. So we find the right partners, we build deep relationships, we hire folks with deep domain expertise who can qualify those, and then we do our own tests. You buy whatever piece of hardware, you test it with the AI in the loop for months, maybe years, before you have the confidence to qualify it for public release, particularly as it pertains to safety issues. If there's a safety issue, you just can't accept a substandard product.
Mm, I wonder, so, like, so I'm just, like, literally taking notes. When you mentioned about, like, safety issues, um, how do you, I guess, like, like, what would you say was, like, the most challenging part about, like, making this robot? And how do you make sure it's, like, safe? Because I think, like, one of the things you mentioned at the beginning was about, like, crashing it, right? So another part is, like, when I'm a UPS or I'm a FedEx, I pick up this box and, like, move it along. There may be, is this, like, the accuracy problem or, like, some other, I guess, like, also, if the box is, like, fragile, like, how do you pick it up versus, like, the suction? I feel like maybe you suck something up, but, like, it drops, or, like, how do you kinda, like, prevent these kind of, um, challenges from like happening?
So I would divide safety into three parts. There's
Mhm,
safety with respect to people, which is
mhm,
the top priority. There's the second part would be safety with respect to the task, like the objects you're handling. You don't want to break them. You handle them safely.
mhm,
And then the third aspect is safety with respect to the robot itself. You don't want the robot to
mhm,
just like whack itself and break itself.
mhm,
Each one has different ways to handle it. When it comes to safety with people, there are a lot of published standards.
mhm,
Unfortunately, the standards are published over a very long time, and they rely on technology that's decades old. So the standard basically can be broken down into two high level rules. The first one is, if a person comes close to the robot, just stop the robot.
mhm,
And that's your standard industrial, what we would call exclusion zoning.
mhm,
The second standard is for lighter weight, what are called collaborative robots. Well, if a robot comes and smacks you, then stop the robot. And
mhm.
I used to always wonder, like, why did they come up with this standard? Because just imagine there's this robot, it's come like smack you, and maybe you're like pinned against the wall, and the robot stops, and you can't even get away. And so people write these standards after debating for a long time, and they come up with what they think is a more pragmatic sort of way to general purpose address it. But I think there's a fundamental problem today with all the safety standards, is that they just focus on stopping the robot, not really doing things in a slightly safe way or allowing people to mitigating damage. And so I think we're going to see the evolution of these standards to allow people to interact with robots in a more sophisticated manner, in a way that really allows robots to be powering people. We're doing some of the work ourselves, and it requires a massive degree of intelligence.
Mhm,
That's going to be technology or 20 years in the future, not 30 years from the past.
mhm,
So, but that's one bucket of work. It needs to be done. And today, we obviously want to be compliant, and we have to rely on decades-old standards
mhm,
to really get there, and decades-old technology. But those are very robust, and I think they provide you a huge amount of peace of mind. They just make sure that your human's like very far away from the robot.
mhm,
The product safety associated with handling items comes down to the AI. Your AI needs to have a very good sense of what it's going to take to not damage product, and that comes down to uh, uh, extreme amounts of quality controls, extreme amount of testing, extreme amount of data collection, extreme amount of training, and what we have. What we call very uniquely our decision engine, which is actively watching. And if it decides that, hey, I'm about to do something unsafe or I'm about to hallucinate, it just like swaps out that AI model and might revert to a different model. Today, when you look at OpenAI's GPT-5, at the back end, it's got many different models. So in the same way, we run many different models, and we'll swap them out and get a different model if it starts to show some unsafe behavior immediately before you even see it.
mhm.
Finally, when it comes to own safety, the robots, you just want to make sure they don't smash into each other. That is we've solved that with some amazing AI that I think is a bit of a trade secret for us, but we're very great at making sure that the robots move with human-like skill. And this was some of the work that built upon the research that we had done at Stanford.
Oh, someone said, don't don't get spam by
I
robots.
do not
Okay.
get stuck by a robot.
So
It's not a good idea.
wanna quickly say hi to the audience. Hi, Nabisha, and hi, Diraj, and then we'll like address your question later. And then Daybreak, like okay, so Daydream said like they don't have like sound. Does anyone else have the issue? I don't think anyone else commented on this, but like please let us know if you don't hear anything. Okay. So, oh, okay, hearing it. Okay, so Jessica, hi Jessica. Yeah, don't smack by a robot. Yeah. Anyway, um, wanted to say hi to like the
The
audience.
best robot is a safe robot.
Exactly. Yeah, I'd be dead if I'm like if like the robot's literally running around like smashing me. But okay, so I wonder when you're thinking about solving these challenges, right? So like Um, I guess, like, on a high level, like, how do people okay, perfect. Okay, she said it's great. Okay, you can hear it. Please, okay, please let us know if anyone else have hearing issues on, like, this session. So, I wonder when you are, thinking about, like, solving these problems, right? So, like, I think in my non-technical mind, how to put together the robot is, like, essentially also, like, from the, observing the companies that have, like I have seen in the past was like people typically buy the hardware and then they program the software. But like, how is the hardware and software combined together? Like, what is the joint part that kind of like implement the hardware and stuff, like, or like combine the software and the hardware? And then also like the other problem is like, how many testing do you have to do to actually find the right pressure, and like how do you kind of like solve the challenges of, let's say it may, it identify something as a human versus like a bot, or like the right amount of pressure to both sucking it up, but also like when you're putting it down, like the same pressure that like doesn't really break the thing. So I guess like how do you solve these like problem to like from like a technical perspective?
So a few different questions there. I'm going to focus on first, how do you get all these different pieces of hardware to work together? You've actually highlighted a problem that's been a massive problem in robotics for the past decades now. And what happens is you buy a robot, you buy a safety sensor, you buy a camera, you buy a hand, you buy the pressure sensor, the force sensor, the touch sensor, some other piece of equipment. Maybe you have a second arm, maybe you've got a rover that drives around. And there was nothing out there in the industry that actually allowed you to seamlessly connect all of these in a way that AI could use them. Again, I'll go back. The most important thing is all of your connected hardware is useless if the AI can't even touch it or feel it or get any signal from it. So the tricky thing over there, and for this, we started an initiative that we call IRIS. It's called the Industrial Robotics Interface Standard, and Intelligent Robotics Interface Standard. And it allows AI to connect to all these different peripherals. It's a standard that we've been working on with some amazing internationally renowned companies. Kawasaki is a manufacturing partner in Japan. Hyven is a manufacturing partner in Taiwan. Beckhoff is an amazing electronics control systems provider from Europe. And we've worked together to just create this language that allows AI to talk to these pieces of hardware in real time and be able to use them. But it's a major outstanding problem in industry.
I guess like when it comes to like building things at scale, right now you guys are $1 billion company. Tell us about like the growth journey as a CEO from like, the PhD at Stanford to like building out the first like, let's say 5 to 10 people core team to like scaling it up into like a $1 billion business.
So I've been very grateful to be surrounded by a close group of friends. We've at Dexterity, we were a bunch of friends. We knew each other. We said, "Hey, let's go ahead and take a shot at physical AI." And physical AI is the dream. I know pretty much every kid at some point of time has been in awe of science fiction, of robots, of AI. It's just so much fun thinking about doing it in a way that's positive for humanity, and being able to do a lot of these heavy lifting things. So we started off with a lot of folks from Stanford, very friendly, almost a bunch of people just working together for a common cause. Our mission is to go out, change the world. It was interesting. One of our founders, one day we were just late at night and working away, and then I said, "Okay, let's just grab a bite." So we went out, and I was like, "Why are we even doing this?" And so he's like, "Dude, we've got to build robots that you just go out, eat asteroids, convert them into space stations, and colonize the whole galaxy." And so that was kind of, became a little bit of a secret mission of ours. Let's just one day we're going to shoot out robots into outer space, and they'll be making spaceships for us out of asteroids, and go out exploring the galaxy. So how did we pull the team together? We just have a lot of fun. We have a good laugh, and we have great dreams and ambitions, but we're also very, very focused on solving real world problems today. So that's been a fun way to do it.
Mm,
Gotta
um,
have a good laugh. If you can't have a good laugh, there's ups, there's downs. It
mhm,
could be very, very challenging. You spent like months trying to do this amazing demonstration for a customer, and the day the customer steps into your building, something weird happens and it doesn't work. How do I get
mhm.
around this? And quickly scramble. So you got to work with people who are willing to just keep a smile on their face and keep going and solve some really, really challenging problems.
I feel like that's super interesting. I love the bonding was about shooting a robot into the galaxy. Um, yeah, I
Yeah.
feel like yeah, that's I feel like that and the what you guys are building right now is like very like the themes like very same but also very outrageous as like, from the robotic hand that pick up your package from Amazon to like shooting stuff to the galaxy. I wonder how do you kind of like find the best metrics to present to, let's say, like each stage of investor or like the benchmark you set for yourself? How do you even set up the benchmark? Because, for example, you've been growing the company for a few years, and from let's say year one to year three, like what kind of like things or milestone that you have to accomplish to, now 7 years later, like, you reach like the $1 billion status. Like, how do you separate the each step of metrics that you have to hit to get to a certain stage? And then also like what like is there like like for the competitive landscape, like I'm sure there's like also other companies that are doing in like a similar ish product, but how do you think about like the differentiations or like the things that you want to focus on versus like things that you feel like we could drop?
So I will start by saying that I'm personally, just humbled by the belief of our investors. I've
Mhm,
never particularly obsessed about these valuations. Stock prices go up, they go down, then they go up again, and the core
mhm,
factor is. Are you solving real world problems, and is the customer able to tell you that you're doing a good job? So the metrics that really matter for us are the metrics that matter for customers, which is
mhm,
how productive are we being?
mhm,
Have we made sure that there are no safety incidents? Like, have we
mhm,
cut down the injury rate? Have
mhm,
we cut down the heat exhaustion rate? Have
mhm,
we got the job done? Were we more reliable and predictable, or did our stuff turn off in the heat of the moment? So there's a basket of customer metrics which we track very, very carefully, mostly centered around how we're empowering people to do these very stressful, laborious tasks like loading trucks. Beyond that, internally, obviously, you have to track revenue.
mhm,
Pretty happy about Dexterity's track record. We've been growing our revenue more than 3x year over year, pretty consistently for now the past 3 4 years. So that's been quite a journey. Um, Apart from that,
mhm,
are we having a good time? Are we creating a foundational company that's gonna have a positive impact on humanity in the long term? Yeah, we got to wake up every day in the morning. It's like, am I gonna have a good time today? Yeah, I'm gonna have a good time today. I'm gonna go out, check out our mechs, loading some trucks. It's got this like cool new kind of move where I call it book shelving. It just learned. Pick up a book and you put it in a shelf. And so these days, when it's loading a truck, it'll pick up this box and kind of like, if it's a narrow box, it like bookshelves it into this like tiny, tight little slot. And I just look
mhm.
at that and I marvel. I was like, wow, man, like 10 years ago, this would have been outright impossible. Like bookshelving a box into a truck with a giant mech robot with two arms that looks like a transformer. I'm just sitting there. This is so much fun.
I love your like enthusiasm to it, and I wonder how do you think about the margins? I feel like hardware is like very famously or infamously being one of the most expensive subcategory to kind of like build in, because of like the profit margin could be very slim. Um, how do you kind of like think about like pricing your product versus like profit margin and stuff?
Yeah. So the when we again, I would say we're predominantly focused on the physical AI. There's when we think about margins, we want to make sure that our core investments are in aspects of the technology that allow us to maintain gross margins at least at par with digital AI, if not better.
Mm.
So if you look at a basket of companies in digital AI, I believe OpenAI has 40 something percent gross margins, Anthropic has 50 something percent. There's a lot of other companies, and the margins come down to how efficient are you with delivering value to the customer, and of your revenue stream, how much of that do you have to spend in just stuff that is always going to be an impediment. Like if you're buying lots and lots of metal, well, that's going to impact your margins. And so the value that is created for the customer, I would say, is predominantly by the AI, by the full system performance.
Mhm.
So that allows us to make sure that we price in a way that is associated with the value. And if the majority of the value is being produced by the AI, then the metal is a minority fraction of the overall spend. And that's how you maintain good margins, is by driving value with extremely sophisticated technology, with extremely sophisticated AI, and with amazing hardware that is designed for AI and serves as a vehicle for the value to get unlocked at customer sites. But
Mm.
would comfortably maintain, I would say, digital AI type margins. So
I think that's very impressive to keep that like a high level of like profit margins. I wonder like what does the sales motion kind of look like? So obviously as a CEO, you have to sell every day, from selling to investors to selling to customers to selling to, vendors to give you a better price to a degree. Like how do you, I guess, like thinking about the actual sales motion to maybe closing a client or investor?
So the sales motion for us, we work with few customers. We carefully position ourselves to deeply understand the customers and drive value for them. So a typical engagement with the customer would start off with us doing sometimes months of very deep research into the market, into the customer's operations, into their core needs, which would lead us to a point where we'd feel some degree of confidence that we'd be able to drive value in the customer's operations. We don't want to waste the customer's time. And once we have a decent confidence about the value, we find a way to get a warm introduction to somebody in the leadership. We only almost exclusively work with enterprises, and these are very large, sophisticated enterprises, very important people. You want to use their time really well. So we walk in, we're well prepared, and we try to make the case that adopting our technology will help them do a lot of this stressful, laborious, injury-prone work with robots, and allow them to have a positive impact on their operations in a way that's going to be well received by the people. And so you make that case, and eventually, if you earn their trust, then they'll give you an opportunity, and you work really hard and you prove yourself. And if they have demands, you say, okay, let's understand where it's coming from. You solve the problem. You continue to make progress. After a while, they trust you more, and then you get more opportunities. It's not like a one and done a sales process. It's a relationship building process over many years, where you consistently show that you're working very diligently. You earn that trust bit by bit, and that gives you the opportunity to do big things.
I wonder for the, fewer client, but very high, like ticket kind of like level of sales motion. I think one of the big challenge would be, or like big fear would be like, what if the industry have some sort of like shift, or or like maybe let's say if you have like, let's say 5 clients and then like you've wound them, peace out, like what your like profit margin is like losing 20%. And how do you think about, or like just the entire, I guess, like revenue lose like 20%, but like how do you think about building out like an ecosystem that like if people leave, like it won't really just like crumble?
So this there's a couple of things when we look at working with large enterprise customers.
Mhm,
You have a high degree of confidence that those customers are going to be around. If you're thinking about
mhm,
the FedExes of the world, these companies are the backbone of our economy. I don't think they're going anywhere. So that's a good one. If you work with very very small customers who might just go out of business tomorrow, that adds a lot of different risks. So the risk profile for us comes not from uh, the customer sort of suddenly evaporating. The risk profile for us comes from, are we solving the critical problems for that customer? If you're solving a problem that's not critical, that's maybe it's a problem today, it goes away tomorrow, then you have a risk of just becoming irrelevant very soon. Or if there's a shift in attention span, you risk just getting the peace out sign.
mhm,
So within large enterprise customers, they have staying power. We have to pick the critical problems, and the critical problems have a big impact. That means that you have their attention. At that point of time, it's execution. Are you doing a good job? And if you're doing very well, you should be able to showcase why you're doing well. If
mhm,
you have challenges, you need to be very upfront. You need to be very honest. You need to take responsibility and say, "Hey, sorry, we were 4 months late at delivering this feature. What can we do?" And customers, I think, at that point of time tend to be very collaborative. They also want to get the job done, and everyone knows it's not a straight line path to success. So I think for us, it's solve the big problems and make sure you execute and be transparent and honest and just work really, really hard.
mm. I wonder, when you mentioned that you would spend, like, months to do the research, um, how do you kind of, like I guess, like, what are, like, the areas that you feel like is, like, the core things that you're trying to get out of it? Obviously, understanding how they pick stuff up, but, like, I think maybe if you just record a video and then you can kind of, like, already know what's going on, but, like, what are the stuff that you feel like were most, like, interesting finding or, like, a earned secret at the beginning that, like, you kind of fun and then, like, how do you kind of, like, find it in the beginning?
I, enormous list of very interesting findings, and there's a if we let's take a bird's eye view
Mhm,
with customers. Even customers that on the outside look very very similar,
mhm,
oftentimes inside the company the operations can be quite different. Let's take two companies like say FedEx, UPS. In Japan, we have Sagawa. In
mhm,
Europe, there's a lot of other e-commerce parcel carriers.
mhm,
They all on the outside might look like, hey, here's a parcel carrier doing a lot of e-commerce shipments and other business shipments and things like that. On the inside, they have their own customers. Uh, their businesses oftentimes are dictated by their customers. FedEx, for instance, started off as an air carrier, so that they used to do air courier, which was amazing. It was a bit of a revolution. Their founder Fred Smith was a famous for taking what was almost inconceivable as a business and making it a global behemoth. And so they've got their operational challenges, they've got their upstream customers. The research that we do is focused on understanding what are their constraints. If they want to make a big bet, what are the problems? What are their top problems? And let's take their top 3 or top 5 problems,
mhm.
and we've got to solve one of their top 3 or top 5 problems. If you're solving problem number 31, good luck. It's just not gonna be that
Mhm,
useful. But if you're solving one of the top 5 problems,
mhm,
then you have to look at other customers. Because if we end up solving a different problem for each and every customer, we're going to get stretched thin. So
mhm,
we look at markets to understand what are the top problems for many, many customers in this market. And
mhm,
then we make sure, okay, we've got a list of these 4 problems. Can we solve them with our application suite? Can we solve them with our AI platform? And if the answer is yes, then part of the research is what is the actual value to the customer solving this problem. So let's take something like truck loading, which is something that we've really, really focused on. Truck loading is a holy grail problem in logistics transportation, because if you're doing anything, you build something in a factory, you put it in a box, it's pretty much it, or a bag, or something, a crate or a container, and you put that on a pallet or in a truck, and then you're moving things around and shuffling them from here to here. So being able to handle boxes and bags and containers and stack them into pallets and load them into trucks is that's pretty much all of logistics. So that's a great problem. Focus on problems like that, figure out the raw impact to the customer, to their operations, and make sure that it's going to be a win-win for them and for us. That's the work that we do.
I love that. Like having priorities on like the problem that you're trying to solve instead of like meeting everybody everywhere, but like just focusing on like the core 80%. I think that's like very, very true. I want to be mindful of the time. Maybe we do like a quick 1 minute fire round for you. What's your favorite book?
My favorite book is, I would say, the Foundation series.
hmm
Yeah.
Who would you invite to your dinner party?
Historically, I would say I'm a bit of a, I love people who are really, really sharp and have some amazing ideas. So out of history, there was Ludwig Wittgenstein. I'd love to have a chat with him. Today, it would be, I would say, Roger Penrose or Elon Musk. I think are two very interesting, charismatic figures. One is a
Mhm.
mathematician, one is a famous technologist.
And hardware founder. So,
Yeah,
uh,
I probably have a lot to learn, and many pitfalls to avoid there.
who made the biggest impact in your career?
The biggest impact in my career, that's a tough one. Interesting. I don't think there's any one. There's numerous, but if I were to call it out, it was the cohort of people who I hung out with at Stanford. These are folks at our labs. There was Professor Usama Khatib in the Stanford Robotics lab, Professor Kwabena Bohan in what was called the Brains and Silicon lab, and our colleagues there. But if we take the Stanford group, that's where I learned everything that I needed to learn about AI, about robotics, and that's been foundational for me as we move forward.
Where can we find you outside of work?
You can find me playing with my kids. I've got a 7-year-old, a 4-year-old, a 7-year-old son. He's just obsessed with creating things and with cars and machines. And my daughter absolutely
Building his,
loves building stuff. So, yeah.
is your whole family building their own bots? Like let their bots talk to your bots kind of vibe?
Not yet. The kids are still young, but I'm pretty sure they'll be building their bots. We have a lot of late nights here, and I get brownie points for being a dad that has some cool stuff in the office. So the kids come in, and there's always candy and they're robots, and so they enjoy.
Love that. Well, Samir, thank you so much for coming on the show today. And also like thank you so much for all the audience who joined in. And then hi Pallavi, want to say hi to everybody. Thank you again. It's such a master class for robotics.
Thank you so much. I really appreciate it. And I loved how you dug in deep to some of the more nuanced aspects of physical AI robotics. There was a lot of new insights, I think, that you pulled out during the conversation. Great work.
Thank you. Let me quickly end stream.